Hello, this is Nitin Dahad with EE Times. I'm talking now to Remi El-Ouazzane, who is with STMicroelectronics. Remi, hello.
Good to see you, Nitin.
How are you?
I'm good. Tired, but good.
So, how's we're Embedded World in Nuremberg? How has it been for you? The show so far? We're halfway.
Very active. We enjoy Embedded World because, contrary to some other trade shows, people that come here are developers
Yes.
and engineers, and we end up with a pretty large presence. Most likely something like around 50 demos downstairs, and it allows us to have good discussion. And I've been spending a lot of time for the past 48 hours with R&D managers or developers of any companies of any size. Sometimes 10 people, sometimes 10,000 people.
Yeah. Wow.
100,000 people. But you learn, every meeting you learn something different. So very happy to be here.
Okay. And the big thing right now is AI and AGI.
Yeah.
But we've been writing about it for several years. I guess the difference now, and I came to your demo suite at CES to see some of the accelerators there. I think the big difference now is just the ability to integrate a lot more compute. Is that right?
Yeah. We are on a path of a tsunami wave of endpoints, and by that I mean sensor nodes, where AI become a first-class citizen feature. And it's not a fad; it's just that actually we see three categories of things: our customers trying to reduce their bill of material, and in doing so, trying to use AI to represent a virtual sensor of any sort.
Okay. Yeah.
We have examples of customers that have been implementing a stochastic function for a long time and are using a probabilistic model to increase the accuracy of whatever they're trying to infer.
Right.
I'll give you some.
I saw the helmet, and I think the stuff they were doing with that.
Okay.
The brain.
Yes,
Yeah.
for an example. And then there is the third category where, well, now that you've got AI functionality into microcontrollers, knowing the low power aspect of a microcontrollers and the lower cost approach of a microcontroller, well, let's invent some new use cases. And what was, burgeoning trend 3-4 years ago is becoming, mainstream. Really.
Mainstream, yeah.
I will tell you, there was not a single meeting this week. And must be piling up to 15-20 meetings now. There was not a single meetings where the word AI were not mentioned. I just met a company without naming them. They are building, on energy harvesting sensors. Great company. And they're now more and more thinking about how they can add intelligence, knowing that obviously the power budget is limited by the fact that they are harvesting the energy.
Yes.
But even for that class of products, they are trying to go and figure out how they can use convolutional model to represent function
In those sensors.
in the sense.
Yeah. Yeah.
So, and it is shown in industrial. It is being deployed in industrial. We have many use cases on our website, and it's actually becoming more and more of a norm in the automotive industry, where so far, AI in the automotive industry was the territory of obviously autonomous vehicle, or was the territory of HPC compute.
Yeah.
And now actually we are finally getting to a mode or to a set of discussion where, either for zonal controllers or either for controllers or either for microcontrollers next to the actuation point, where actually AI is becoming a reality. AI at the edge can mean
So many things. Yeah.
Okay.
And
So I will tell you how I define what we own in ST.
Yep.
Because I think we've been at the forefront of all of this. We own all the boring use cases. We are doing everything but the sexy use cases. We can tell you if your tire is going to get flat, if your fan is about to go and get bankrupt in a data center. We can infer a license plate. We can infer whether or not the temperature of the rotor of your autonomous vehicle is actually overheated.
yeah.
We can also tell you if one of the cells in your battery management system is about actually to go get into thermal runaway. I'm not doing sexy stuff, but I'm doing many unsexy but super exciting stuff for us.
Well, yeah, I mean, that's true because in the media, we tend to write more about the sexy stuff. But I think what is quite important is there's so many other applications. And I think you've just highlighted a lot of them. So, yeah.
And it's exciting because, when you look at the general purpose microcontroller, at least part of the market, which is, talking about that because this is really an industrial trade show here. I would say, per annum, maybe 10 billion of them are shipping. 10 billion nodes are shipping every year. So I will tell you that it will not be the the highest dollar value. Obviously, if you look at the cost of large-scale GPUs into data centers, it's another of magnitude.
Yeah.
But in quantum, in volume, if we speak again in 5 years from now, by far, it will be the largest instantiation of intelligence being deployed in the world. Just because actually you will see intelligence push more and more at the far end next to the sensor.
Okay. You're in more than just AI, and you're into the cars, you're into mobiles. What are the big trends you're seeing right now where you sit at ST?
Obviously, we look at electrification as a massive trend. And it's true for us across our entire portfolio, both from a power standpoint to also actually how our digital products like microcontrollers are being used. Can be true, as true as in a solar inverter, as much as in a traction inverter for powertrain of an automotive, or actually for what will end up being your power supply unit in your next generation data center, So power electrification is going everywhere.
Yeah.
It's definitely a very big trend. I would say autonomousness is a big trend. Obviously, about the autonomousness approach through the lens of the past 10 years of ADAS and autonomous vehicle. But it's just actually the beginning of a large trend. I think that actually we believe in a world of cloud-connected intelligent device, where essentially, many of those endpoints out there will proactively actuate. It can be something that you don't even notice.
Robotics, industrial. Yeah.
Actually, there are robotics industrial. There are so many use cases at home, where essentially the actuation can be done because you're receiving XYZ signals that you can use to go and infer an action.
Yes. Yeah.
And so the world around us digitally is going to be more and more autonomous.
Yeah.
And I think that's another, I would say, a big trend that we see and from which we derive a lot of things. Clearly, the other big trend that we believe in is what's happening more on the infrastructure side. I come from that world, and I may be saying something that is going to be contentious, but it's good for.
I'm looking at your colleagues around here, so
that's starting to get more. Yeah. I do not believe that there is much evolution that will happen in compute or in memory in data center. I don't think this is a problem anymore.
Okay.
I think that actually the real problem in data center is how you're delivering thousands of amps efficiently to an XPU, and way more importantly, how those XPUs are going to be interconnected. We can all read the same things.
Yeah.
We're getting to a million XPU instance class compute cluster, all interconnected. So I think actually the two pieces of technology that will be the most important for the coming decade of cloud AI will be power and will be actually optical interconnect. And let's see if I'm going to be right.
We're seeing a lot on the optical interconnect already. We're in the market, so I think that it's happening already, I guess.
Yes, it's happening for sure, and it was for us it was a big inflection point. You may have seen that we've announced something around that line a few weeks ago. We clearly, EML is getting to an end. And we believe that for the next generation, 800 gig and above, the need for silicon photonics is obvious.
Yes.
And, we are ST. If you have to go and remove everything and go to the core of what ST is a material science company.
Yeah.
We build processes. And we know how to bring them to scale, and we know to bring them to scale with very high quality. Is what makes ST so special for its customers, and some of them are very well known out there.
Yeah.
And silicon photonics is a perfect example of ST at its best because it's a complex process. It's actually it's involved different classes of material. It's involved actually the utilization of an SOI substrate that we have already mastered over the years. It's really a perfect illustration of what we can do at best, and we'll have a lot of news on that silicon photonics topic that you will see in the coming quarters and years.
Oh, okay, all right. I mean, I did moderate a panel at OFC last year on the topic was, is AI going to be the killer application for silicon photonics? Now, we had NVIDIA, we had a few other people on the panel, and I think the challenge is just getting the scale of manufacturing, and so that's what was coming out in the panel, and also the tools to enable design, just like normal CMOS system design.
Yes, no, you're spot on. It was a big step for us. When we engage on silicon photonics, we have multiple choices, but we did not flinch. We went straight to our 12-inch fab. When you build on 300 millimeters, a lot of goodness comes. And one of the goodness is obviously not only the scale of volume, but it's also the yield that you can actually extract.
Yeah.
And as to the EDA toolchain, that's a real topic of discussion.
Yes. Well, we won't go there now, I guess.
I bet not, but I see some more progress to go through.
Yeah. So I mean, those are the big trends, I guess. Also, I think I'm seeing all your competitors and you all chasing the same thing. What sort of helps you to stand out with ST? I know you say you're doing all the real sort of non-sexy applications, but what do your customers say about you?
Look, at the end of the day, we can all agitate ourselves, but eventually there will be a developer in a dark room that is going to get access to our stuff and need to do stuff with it.
Yeah.
Okay. So the jury, I think, is in the quality of your developer environment, the quality of your developer tools. But it's not only, to do a flashy UI and flashy whatever. It's also, the way you approach your community, the way you groom your community, your support channel, the way you measure on a monthly basis the satisfaction of your developer community so that you understand their pain point.
You've been doing the development environment for a long time anyway.
Yes, yes, we have a lot of data, but I will surprise you. It's like an infinite road because always we have to go and upgrade our game in terms of the quality of IDE, the functionality of our IDE, the easiness for you to go and, to use a very basic example, the logging mechanism that we are using within ST to go and allow developers to get access to our tools, the ability for those same embedded software to be not only available for our tools, but also available for GitHub, and on and on and on. And so we are accumulating a lot of mileage around that. The second thing that you also, I think you will resonate with that, is that actually the CEO of Microsoft said that one time, and I think he was very right. There is something that you cannot take back, and that is time.
Yeah.
So, and for developers, the time of our developers needs to be considered as a very precious thing. So I will give you a heads up on what we're going. It's actually already running in the background, but will be going live in a quarter from now. And this is actually being deployed first in the context of SCM32. We are actually using GenAI to go and allow our support community to have instance responses to queries. Before that, humans were in the loop. Humans will still be in the loop for supervision.
Yes.
But actually, we've been training GenAI on our products, all STM32. But it was a real journey to get there.
Right.
So that actually we can enable a much more rapid response to developers.
And faster deployment, I guess.
And this will translate eventually into faster deployment.
Yeah.
They can ask any questions because we've really trained it, and we've worked very hard to go and reduce the amount of hallucination in the system, to go and allow actually to sure there was not a lot of it's impossible to remove hallucination, but at a point where it's an acceptable level of hallucinations in the system. But that is why I'm talking about that. It's not so much to brag because it's it's hidden. You won't see it, but it's actually more to go back to the origin of your question, which is at the end of the day, it's all about developer engagement. It's all about how developers have an easiness to engage, in that case with our microcontrollers, and get their project to completion.
Okay. I suppose finally I want to ask you, what excites you right now in the era we're in this age of AI, generative AI, and what you're doing? What excites you?
I think what I get a kick out of is how it's not only about enabling AI in our customers' use cases. It's how they're also transforming their business model. I won't name that company, but when you are actually a company developing large-scale fans that are being deployed in hyperscalers, and actually some of those fans end up not being working, thermal dissipation impact is such that the hyperscalers may have to go and actually shut down part of the park. That is straight dollar, right? But then actually, if you have the ability to preemptively know what's going to happen in your given fan, then you also can change the business model engagement you have, not me, but my customers, together with that hyperscaler. And what I find fascinating here for us is not only the enablement of a new use case or a more efficient use case, but it's also how they're transforming their business model by adding intelligence, a cloud-connected intelligence into their device, and how they use that to, digitalize themselves. And in the industrial world, it's a big deal. We deal by reading every morning the latest news of AWS, Azure, or what Meta or Apple are doing. But this is not that world. That this is a world of that is often moving slow and often has not been fully digitalized. And here, what I see is they are really embracing it, and I get a kick out of this. And this is why I was very happy to come here this week.
Well, Remi, thank you very much.
My pleasure, Nitin.
Thank you.